Okay, this is McGraw-Hill Chapter 6, Section 7, Solving Rational Equations. Make sure you understand that the one with the imaginary numbers is Section 8. I know I say Section 7 on the other. I have to change that. Alright, so here's what happens. Here's example 1, page 547. You can see that we have the square root of p plus 5 equals 9. We're going to just use algebra to solve. Subtract the 5 over. We get 4. Square both sides so we can get rid of the square root, and then it becomes just p equals 16. Looking at example 2, same thing. We're just going to use algebra to solve. We have cube root of w minus 1 minus 2 outside the cube root plus 2. So we're going to add the 2 over first. We get 4. We're going to cube both sides. So that gives us a w minus 1. 4 cubed is 64, add the 1 over, we get 65. It's really pretty understandable. And in these problems, I'm never going to give you a fourth root or a fifth root. It's always going to be square root or cube root. So in the example problems in the book, there may be some fourth root problems there. I'm not going over them because I'm not going to give them to you. Here's example 4. We have y plus 2, square root of y minus 3 equals 3. Well, I rearranged it. I put the 2 square root of 4y minus 3 in front and the plus y in the back equals 3. So now I'm going to subtract the y over. And then what we're going to do is square both sides. I'm going to square the 2 square root of 4y minus 3 and square the negative y plus 3. When we square this, we get 4. And then, of course, the square root goes away, so it's 4 times 4y minus 3. When we square this, we have negative y plus 3 times negative y plus 3, which gives us y squared minus 6y plus 9. We distribute this 4 here, we get 16y minus 12. Now we have to do is just move it around and collect like terms. So what I did was move this, I switched sides. I moved the trinomial to the left, binomial here. I subtracted the 16y, I got negative 22y, added the 12 and got 21. So subtracted here, added here, and then switch sides. This factors into y minus 21 times y minus 1, which gives us an answer of y equals 21, y equals 1. You should always go back and put these in. You know, you put the 1 in and check it to make sure it works. You put the 21 in and make sure it works too. Okay? This is example 5, page 549. This is cube root of 2x minus 4 equals cube root of 1 minus x, 8x. What we're going to do is cube both sides. That gives us 2x minus 4 equals 1 minus 8x. I'm going to add this 8x over. I get 10x minus 4 equals 1. Two-step form. Add 4. Divide by 10. I get x equals 1/2. Now, whenever you get a problem where you have 2 square roots in the problem or 2 cube roots in the problem, that's just telling you you're going to have to square twice or cube twice. And here's how it works. What you want to do is you want to add the square root of 4 plus m over. So you want a square root on either side. You don't want 2 square roots on one side or 2 cube roots on one side. Next thing we're going to do is square this. So when we square root of 3m plus 1, it gives us 3m plus 1. When we square here, we got to go 1 times 1, which gives us 1. We got to go 1 times square root of m plus 4, and then m square root of m plus 4 times 1, which gives us 2 square root of m plus 4. And then square root of m plus 4 squared is m plus 4. Now we're going to collect like terms. Subtract this m over, we get 2m. Subtract the 5, because it's 5 over, we get minus 4. Divide by this 2, we get m minus 2 equals square root of m plus 4. Square both sides. This, of course, is m minus 2 times m minus 2, which gives us m squared minus 4m plus 4. Square root of m plus 4 squared gives us m plus 4. Subtract the m over, we get minus 5m. Subtract the 4 over, they cancel. Factor out an m, and we find out m equals 0 for this m, and m minus 5 equals m minus 5. I mean, m minus 5 equals m equal 5. So our solutions are 0 and 5. It's really pretty simple.